This is the second video on implicit differentiation, where we're going to have a look at two different examples. So here's the first example. We're asked to find the equation of the tangent to this curve at the point when x is 1 and y is 1. So as usual, when we want the equation of the tangent, we need to get the gradient. To get the gradient, we're going to need to differentiate this. So, differentiating both sides here with respect to x. Now, when I'm differentiating this, we can see I've got a product of two functions. I've got the 4x and I've got the y squared. So I'm going to need to use the product rule to differentiate this. So, differentiating the 4x first of all, that's simple. So differentiating the 4x will give me 4. That needs to be multiplied by the y squared. So I differentiate the 4x, times it by the y squared. Now, I need to differentiate the y squared and times that by the 4x. So I'm going to write the 4x there. Now, differentiating the y squared, I can't differentiate that with respect to x, but I can differentiate it with respect to y. So differentiating this with respect to y will give me 2y, and I'm allowed to do that as long as I multiply by dy by dx. So you can see this is going to simplify, so the 4 and the 2 will give me an 8. So I'm just going to rewrite that as an 8xy dy by dx. Okay, so that's differentiating this part here. Now I'm going to need to differentiate this term here, the 6x squared over y. And I'm going to use the quotient rule to do this. So, first of all, differentiating my 6x squared. Well, that's nice and simple. That's going to give me a 12x, and that needs to be multiplied by the y. Now I need to differentiate the y and multiply that by the 6x squared. So differentiating the y, I can't differentiate that with respect to x, but I can differentiate it with respect to y. When I differentiate that with respect to y, I will get 1. So I'm allowed to do that as long as I multiply by the dy by dx. So what I will get there is dy by dx. So that's differentiating the y. That needs to be multiplied by the 6x squared. And when you use the quotient rule, you take those away. And all of that gets divided by the denominator squared. So this here is your quotient rule. On the right hand side over here, differentiating this with respect to x will give me 0. Okay, next step is to simplify this and make dy by dx the subject. So I'm going to get rid of the y squared, so I'm going to multiply everything through by y squared here. Okay, right, everything that has a dy by dx, I'll leave it on the left hand side. Anything that doesn't, I'm going to stick it over to the right hand side. So on the left hand side, I'll be left with these two terms. And on the right hand side, I've got the minus 4y to the power of 4 minus 12xy. Make dy by dx the subject. by factorising. And dividing. Okay, right. That's my gradient function then. And I wanted to work out the gradient at the point 1, 1. So x is 1 and y is 1. So let's substitute those in. So I will get minus 4 minus 12 over 8 minus 6, which is minus 16 over 2, which is minus 8. So my gradient is minus 8. And from there, I can do y equals mx plus c. I know y is 1 and x is 1. So c must be 9. And there we go. I've got the equation of my tangent at the point 1, 1. Second example. So we want to just, in this example, we just want to find the value of dy by dx, again at the point 1, 1. It won't always be 1, 1, that's just the coincidence of the two examples I've picked to have a look at. So what we're going to do, just the same as before, we're going to differentiate both sides of this with respect to x. We are going to need to use the product rule here, because we've got the product of two functions. So differentiating the exponential, I'm going to have 2e to the 2x multiplied by ln y. Now differentiating the ln y, well, I can differentiate that with respect to y and get 1 over y, which I'm allowed to do as long as I multiply by dy by dx. So I've differentiated the ln y, and that needs to be multiplied by e to the 2x. So I've used the product rule here. Differentiating the right-hand side, well, differentiating the x will just give me 1. Differentiating the y with respect to y gives 1, and that needs to be multiplied by dy by dx. Differentiating the 2, well, that disappears. Okay, right, let's collect up the dy by dx terms. So if I put them both over to the right-hand side over here, so I'm going to leave the 2e to the 2x ln y. I'm going to bring this 1 over to this side. So my 1 times dy by dx, and I've got my minus 1 over y. Like that. Because I've got this awkward fraction here, I might actually multiply all the way through by y just to simplify this a little bit before I do the factorising. So if I do that, I will have y times e to the y times 2e to the 2x ln y minus y equals y times dy by x minus dy by dx e to the 2x. Just by doing that, it's going to make the division that I do in a moment a little bit neater. So factorise over here. So I'm going to leave what I've got on the right hand side here. Factorising the dy by dx. And dividing. So dy by dx is equal to Oh, I've just realised I've forgotten the 2 here. Okay, there we go. Now what I would need to do is substitute the coordinate in, because it said the value. So substitute the coordinate 1, 1 into this. So 2 times e to the power 2, so 2 times 1 times e squared, because the 2 times the 1 there, times ln 1 minus 1 all over 1 minus e squared. Now actually ln 1 is 0, so this whole thing is 0, so I get minus 1 over 1 minus e squared, which I could write a little bit nicer, more nicely, as that. There we go.